Okay, so it is the second part of metals and non-metals. Okay, so kindly subscribe my channel and like, share and comments the video. Okay, at first topics, ionic or electrovalent bond or compound. Okay, so what is ionic or electrovalent bond? देखो, sodium and chloride's ions are oppositely charged. We all know that sodium positive and chloride negative ions. Okay, so uh, as they are oppositely charged, attract each other. Okay, are held by a strong electrostatic force of attractions to exist as sodium chloride, resulting in formation of an electrovalent bond or an ionic bond. Okay, because of oppositely charged and electrostatic force of attractions to exist as sodium chloride. Okay, to exist as sodium chloride, resulting in a formation of electrovalent or bond or ionic bond. Okay, this is the concept. ओके देखो, इसका सोडियम क्लोराइड का एक जियोमेट्रिकल शेप है. ओके, exist as a aggregate of oppositely charged ions, okay, in definite geometrical shape. Okay, now what is electrovalent compounds? Okay, यहाँ पे हम देख रहे हैं इलेक्ट्रोवैलेंट बॉन्ड और यहाँ पे देखूंगा हम इलेक्ट्रोवैलेंट कॉम्पाउंड्स. ऑब्वियसली सोडियम क्लोराइड एक इलेक्ट्रोवैलेंट कॉम्पाउंड्स है. कैसे? देखो देखो, such bond, electrovalent bond is formed by give and take of electron, is called as ionic or electrovalent bond. Okay, तो जो बॉन्ड आयोनिक और इलेक्ट्रोवैलेंट बॉन्ड प्रोड्यूस हुआ है वो बेसिकली गिव एंड टेक ऑफ इलेक्ट्रॉन हुआ है यहाँ पे. ठीक है, compounds formed in this manner by the transfer of electrons from a metal sodium to a non-metal chloride are known as the ionic compound. Okay, so sodium chloride एक ionic compounds है. Okay, now next coming to the another concept, what is covalent compound. यहाँ पे गया है ionic compounds, now comes to the covalent compound. देखो, chemical compound that formed by mutual sharing, this is the concept, mutual sharing of वन और मोर पेयर्स ऑफ इलेक्ट्रॉन. वन पेयर भी हो सकता है और मोर पेयर भी हो सकता है. वन और मोर पेयर्स ऑफ इलेक्ट्रॉन बिटवीन टू कॉम्बाइनिंग एटम इज कॉल्ड कोवैलेंट कंपाउंड. व्हाट इज द एग्जांपल ऑफ कोवैलेंट कंपाउंड? दैट इज वाटर, एमोनिया. ओके, यहाँ पे देखो मैंने एक स्ट्रक्चर किया है. ये है एमोनिया का स्ट्रक्चर, ये नाइट्रोजन है, एमोनिया का 3 हाइड्रोजन है. ओके, यहाँ पे देखो एक बॉन्ड है. इच बॉन्ड में 2 इलेक्ट्रॉन है, 1 2. एक इलेक्ट्रॉन हाइड्रोजन से आता है और दूसरा इलेक्ट्रॉन नाइट्रोजन से आता है. ये 2 इलेक्ट्रॉन म्यूचुअल शेयरिंग होता है. इस 2 इलेक्ट्रॉन का म्यूचुअल शेयरिंग होता है, मतलब हाइड्रोजन भी इसको यूज़ करता है, नाइट्रोजन भी इसके यूज़ करता है. इस बॉन्ड में सेम मैकेनिज्म है, इस बॉन्ड में भी सेम मैकेनिज्म है. इस इज म्यूचुअल शेयरिंग. ओके, एमोनिया इज अ म्यूचुअल को एमोनिया में नाइट्रोजन और हाइड्रोजन का म्यूचुअल शेयरिंग हो रही है. सो एमोनिया इज ए कोवैलेंट कंपाउंड. देखो वाटर का फॉर्मूला है H2O. ओके, सो देखो यहाँ पे एक बॉन्ड है, यहाँ पे एक बॉन्ड है. ओके, सो यहाँ पे 2 इलेक्ट्रॉन्स से, 1 electrons coming from hydrogen and another electron coming from oxygen, and both 2 electrons are shared by oxygen, used by oxygen and hydrogen. Okay, and there is a formation of bond. This is called covalent bond, and this total compound is called covalent compound as they form covalent bond. Okay, this is the concept between ionic or electrovalent bond and covalent compound or covalent bond. Okay, now properties of ionic compounds. Okay, ionic compounds are solid and hard because What is the cause? Because strong force of attraction between positive and negative ions. Okay, this is the first property. Okay, the second property is they are generally brittle, okay, and break into pieces when pressure applied. Okay, this is the second point. And third point is ionic compounds have high melting and boiling point. Okay, why? As considerable amount of energy is required to break the strong intermolecular attractions. Okay, this is the cause of high melting and boiling points of ionic compounds. Fourth properties, okay, they are generally soluble in water and insoluble in solvents such as kerosene, petrol. Okay, now fifth properties of ionic compounds about conduction of electricity of ionic compounds. देखो ionic compounds क्या होता है in solid state. Okay, in solid state do not conduct electricity. Why? Because the movement of ions in the solid state is not possible due to their rigid structure, but they conduct electricity in the molten state. Okay, in the molten state ionic compound conduct electricity. The conduction of electricity through a solution involves the movement of charged particle. Obviously charged particle causes conductions of electricity. A solution of an ionic compound in water contains ions which moves to the opposite electrodes when electricity is passed through the solutions. Okay, cathode anode hai, we know all that. Cathode is negative, anode is positive. Ionic compound negative, suppose it is positive ion goes towards the cathode, and chlorine minus negative ion goes to the anode. Okay, this is the process when electricity is passed to the solution. यहाँ पे solution रहता है when electricity is passed to the solutions, then ionic compounds goes towards the electrodes. Okay, so that's why the conductions of electricity through a solutions involves the movement of charged particle. Okay, coming to the next topics, occurrence of metal. Okay, देखो, the most unreactive metals, not unreactive means not affected by air and water. Example given, silver, gold, platinum are generally found in free or native state. Okay. However, most metals are found in combined state in the form of their oxides ore, carbonate ore, or sulfide ore, etc. Okay, this is the concept. Now, what is the definitions of minerals and ores? Okay, at first minerals. What is minerals? Minerals, naturally occurring compounds, obviously, of metals. Naturally occurring compounds of metals along with other impurities are known as minerals. And what is ores? The minerals from which metals are extracted. The minerals from which metals are extracted profitably. This is the point. Profitably and conventionally are called as ores. ओके, यहाँ पे देखो व्हाट इज गैंग एंड व्हाट इज मेटलर्जी. ओके, देखो व्हाट इज गैंग. देखो ore contains metal compounds. Obviously ore contain metal compounds with some of the impurities, okay, like soil, sand, rocky material, etc. These impurities are called gang. Okay, these impurities are called gang. Next comes to the what is metallurgy. Okay, what is metallurgy? देखो metal can be extracted from the ores, obviously, by employing different separation technique. The processes used for extractions of metals in their pure form. Okay, processes used for extractions of metals in their pure form from their ores is called metallurgy. Okay, so simple. Okay, This is activity series and related metallurgy. Okay, this is basically reactivity series of metal, the arrangement of metals in the decreasing order of their reactivity. Okay, decreasing order of their reactivity. देखो मतलब एकदम टॉप में जो है उसका मोर रिएक्टिव देन द बॉटम. ओके, यहाँ पे डिक्रीजिंग ऑर्डर में इसको डिक्रीजिंग ऑर्डर को इसको अरेंज किया गया है. ओके, दिस इज रिएक्टिविटी सीरीज. ओके, सो thus the most reactive metal is potassium. Okay, so most reactive metal is potassium, is placed in the top. Okay, is placed in the top, and the least reactive metal is gold. Okay, least reactive metal is gold, Au, and placed at the bottom. Okay, so this is activity series and related metallurgy. Okay, देखो 3 categories of metals are available. Okay, first, metals of high reactivity, metals of medium reactivity, metals of low reactivity. Okay, देखो extractions of metals of high reactivity. देखो metals high up in the reactivity series are very reactive. Example given sodium, potassium, calcium, aluminium, etc. These metals are obtained by electrolytic reductions. Okay, sodium, magnesium, calcium are obtained by electrolysis of their molten chlorides. Okay, so what happened there? The metals are deposited where? On the cathode. Okay, cathode is negatively charged and metals are positively charged. As a result of this, metals are deposited at the cathode, whereas chlorine is liberated at the anode, as chlorine is negative and anode is positively charged electrodes. The reaction of sodium as follows. कैथोड में क्या रिएक्शन होता है एंड एनोड में क्या रिएक्शन होता है? देखो, सोडियम कैथोड में 1 इलेक्ट्रॉन लेता है. ओके, टेक करता है, देन कन्वर्टेड इनटू सोडियम, एंड एट एनोड क्लोरीन मतलब 2 इलेक्ट्रॉन एनोड में देता है. ठीक है, chlorine gives 2 electron to anode. Okay, this reaction is written here. Okay, देखो extractions of aluminium. Okay, this is some information about aluminium. Aluminium silvery white. Okay, atomic number 13, इलेक्ट्रॉनिक कॉन्फ़िगरेशन 283, मतलब KLM. शेल जो है, के शेल में 2 इलेक्ट्रॉन, एल शेल में 8 इलेक्ट्रॉन एंड एम शेल में 3 इलेक्ट्रॉन. व्हाट इज़ द वैलेंसी? वैलेंसी 3. आउटर शेल में जो इलेक्ट्रॉन है वही वैलेंसी है. ओके, वैलेंसी 3. एल्यूमिनियम इज अ रिएक्टिव मेटल. ओके, एंड एल्यूमिनियम एक्सट्रैक्टेड फ्रॉम its main ore bauxite. Okay, this is very important. What is ore of aluminium? That is bauxite, and इसका formula है Al2O3.H2O. Okay, bauxite contains 30% to 70% aluminium oxide, Al2O3. Okay, then aluminium is obtained by electrolytic reduction of aluminium oxide, and the remaining portion is gangue. This remaining portion is gangue made of sand, silica, SiO2, and iron oxide, Fe2O3, etc. Okay, this is extractions of aluminium. ओके, यहाँ पे देखो बॉक्साइट माइनिंग का इमेज है. ओके, ये अनमाइंड लैंड है, अनमाइंड लैंड. दिस इज टॉप सॉइल स्ट्रिपिंग. दिस इज द प्रोसेस कॉल्ड टॉप सॉइल स्ट्रिपिंग. देन एक्टिव माइन पिट. ओके, दिस इज एक्टिव माइन पिट, एंड दिस इज माइंड आउट पिट. ओके, माइंड आउट पिट showing regolith material. Okay, regolith material. What is regolith? Regolith is unconsolidated solid, okay, unconsolidated solid. Okay, देखो, extractions of aluminium involves two steps, okay. This is first step. What is first steps? Concentration of ore. What is concentration of ore? That is conversion of bauxite into alumina, okay. This is by Bayer's process, okay. This is by Bayer's process, okay. So देखो देखो what is the first step. यहाँ पे क्या होता है ना, क्रूड बॉक्साइट जो है वो कंटेन्स impurities like iron oxide and silica. These impurities are removed by Bayer's process, okay. This is very much important question, Bayer's process. In this process, the ore is first crushed and then treated with what concentrated caustic soda solution under high pressure for 2 to 8 hours at 140 degrees centigrade to 150 degrees centigrade in a tank called digester, okay, in a tank called digester, okay. Aluminium oxide being amphoteric in nature, okay. Aluminium oxide का acidic character भी है, basic character भी है, so it is amphoteric in nature. We all know that dissolves in aqueous sodium hydroxide, okay. Aluminium जो oxide है dissolves in sodium hydroxide to form water soluble sodium aluminate, okay. This is a salt. Water soluble sodium aluminate is formed, okay. The iron oxide in gangue does not dissolve in aqueous sodium hydroxide, okay, and is removed by filtration, okay. So simple. Does not dissolve in aqueous sodium hydroxide and is removed by filtration. However, silica from the gangue dissolves in aqueous sodium hydroxide forming water soluble sodium silicate, okay. Now क्या प्रोड्यूस हुआ है? सोडियम एल्यूमिनेट. यहाँ तक क्या प्रोड्यूस हुआ है? सोडियम एल्यूमिनेट. नाउ व्हाट शुड बी डन? डाइल्यूटिंग sodium aluminate with water, okay, diluting sodium aluminate with water and then cooling to 50 degrees centigrade and it is hydrolyzed to give aluminium hydroxide as precipitate, okay. देखो hydrolyze होकर sodium hydroxide and aluminium hydroxide precipitate produce हुआ है, okay. Then the precipitate is filtered, washed, dried and ignited. Ignited means catch fire, okay, ignited at 1000 degrees centigrade to get alumina. Alumina is Al2O3 and देखो reaction देखो, aluminium hydroxide को 1000 डिग्री सेंटीग्रेड में हीट किया गया है एंड प्रोड्यूस हुआ है alumina, that is alumina Al2O3 plus 3H2O, 3 molecules of water, and in this process alumina is produced, okay. This is flow chart of Bayer process by which aluminium oxide is produced from its ore bauxite, okay. देखो एट फर्स्ट बॉक्साइट को क्रशिंग एंड मिलिंग किया है, देन एक प्रेशर्ड वेसल में लिया गया है, ओके. देन एडेड सोडियम हाइड्रोक्साइड्स एट टेम्परेचर 170 to 180 डिग्री सेंटीग्रेड, ओके. देन filtering the gangue material, okay, that is red mud, okay. Then what is formed sodium aluminate and water complex form में लिखा गया है. then इसको कूल किया है, कूलिंग किया है. after that water is added, okay, and aluminium hydroxide precipitate is formed. then aluminium hydroxide precipitate को, okay, ignited किया गया है. then 1000 डिग्री सेंटीग्रेड में 1000 डिग्री सेंटीग्रेड में ignited किया गया है. then aluminium oxide is formed. this is the all over flow charts of Bayer's process. so what is rotary kiln? यहाँ पे लिखा हुआ है रोटरी किल्न. रोटरी किल्न एक पायरो प्रोसेसिंग डिवाइस है, ओके, जहाँ पे मटेरियल को हाई टेम्परेचर में ले जाने के लिए यूज़ कर जाता है, ओके. रोटरी किल्न यहाँ पे एल्यूमिनियम हाइड्रोक्साइड को 1000 डिग्री सेंटीग्रेड में इग्नाइटेड किया गया है और कैच फायर करता है, तो रोटरी किल्न यूज़ होता है जहाँ पे हाई टेम्परेचर में एल्यूमिनियम हाइड्रोक्साइड को इग्नाइटेड किया जाता है और ओके, दिस इज रोटरी किल्न. Okay, now step 2, electrolytic reduction of alumina. Okay, in this process a molten mixture of pure alumina जिसका melting point 2000 डिग्री सेंटीग्रेड 2000 डिग्री सेंटीग्रेड से भी ज़्यादा है. In this process a molten mixture of pure alumina is electrolyzed in a steel tank. Okay, this is a steel tank. This tank is lined inside with carbon. Okay, inside में है lined by carbon, that is graphite, which acts as a cathode. Okay, देखो carbon cathode, that is graphite, and set of carbon graphite, and set of carbon graphite, this one, set of carbon graphite rods dipped in the molten electrolyte act as a anode, that is positive charge. Okay, now cryolite, okay, Na3AlF6 इसका फॉर्मूला है cryolite, and fluorspar CaF2 is also added to the mixture. Okay, देखो, okay, cryolite and fluorspar is added to the mixture. Okay, why this cryolite and fluorspar is added? To reduce the melting point to about 1000 डिग्री सेंटीग्रेड. ओके, हम लोग यहाँ पे देखा है इसका मेल्टिंग पॉइंट है 2000 डिग्री सेंटीग्रेड, बट बाय मिक्सिंग cryolite and fluorspar to the mixture to reduce the melting point to about 1000 degree centigrade. Okay, now on passing the current, aluminium is formed. Okay, at the cathode. Okay, cathode is negatively charged and aluminium is positively charged, so aluminium is formed at the cathode. The molten aluminium being heavier than the electrolyte used. Okay, जो electrolyte यूज होता है इससे molten जो aluminium प्रोड्यूस होता है वो heavier होता है, molten aluminium heavier, so it sinks, molten aluminium sinks to the bottom of the tank from where it is removed periodically. Okay, it is removed periodically, not in one time all is removed. Okay, it is removed periodically. On the other hand, oxygen is liberated at the anode. Okay, anode is positively charged electrode, so oxygen is negatively O minus, so oxygen is liberated at the anode. So this is the reactions. anode में क्या होता है, ऑक्सीजन एनोड में ऑक्सीजन क्या होता है, 4 electrons give to the anode and form oxygen. In cathode में क्या होता है, Al3 plus 3 electron taking from cathode. Okay, they form aluminium. Okay, the oxygen gas liberated reacts with carbon anode. Okay, जो ऑक्सीजन गैस लिबरेट होता है वो कार्बन जो एनोड होता है ना, कार्बन जो एनोड है, and forms carbon dioxide, react with carbon anode and form carbon dioxide. As the anode gets oxidized, so what happened, anode is oxidized in the electrolysis of alumina, so it has to be replaced from time to time. As it is oxidized, it has to be replaced from time to time. Okay, next coming to the extractions of metal of medium reactivity. Okay, देखो, the metals in the middle of activity series such as iron, zinc, lead, copper, etc. are moderately reactive. Okay, these are usually present as, okay, this medium reactivity जो metal है वो कैसे नेचर में रहता है, कैसे प्रेजेंट करता है, वो usually present, these are usually present as sulfides or carbonates in nature. Okay, sulfides or carbonate in nature. It is easier to obtain a metal from its oxide as compared to its sulfide and carbonates. Okay, it is easier to obtain a metal from its oxide than to its sulfides and carbonates. Okay, देखो the sulfides ore are first converted, देखो यहाँ पे रिएक्शन देखो और डिस्क्रिप्शन देखो. It is sulfide, zinc sulfide. Okay, the sulfide ore are first converted into oxides. First converted into oxide, as it is very much easy to get metals from its oxides. Okay, so at first the sulfides ore are first converted into oxides by heating strongly in excess of air. Okay, by heating strongly in excess of air. This process is called roasting. This is very much important. Okay, the sulfide ores are first converted into oxides by heating strongly in the excess of air. This process is called roasting. Okay, यहाँ पे देखो कार्बोनेट ओर में क्या होता है, द कार्बोनेट्स ओर आर चेंज्ड इनटू ऑक्साइड बाय हीटिंग स्ट्रांगली इन लिमिटेड एयर. देखो कार्बोनेट जो ओर है वो स्ट्रांगली हीट करता है इन द प्रेजेंस ऑफ ए लिमिटेड एयर एंड इट फॉर्म्स ऑक्साइड. देखो जिंक ऑक्साइड एंड कार्बन डाइऑक्साइड प्रोड्यूस हुआ है. दिस प्रोसेस इज नोन एज कैल्सिनेशन. ओके, द कार्बोनेट ओर आर चेंज्ड इनटू ऑक्साइड्स बाय हीटिंग स्ट्रांगली इन लिमिटेड एयर. दिस प्रोसेस इज नोन एज कैल्सिनेशन. ओके, सो this is very important, the definitions of calcinations and definition of roasting. और यहाँ पे देखो रोस्टिंग इनके कैल्सिनेशन का जो केमिकल रिएक्शन है वो यहाँ पे दिया हुआ है. ओके, then what happened, then zinc oxide is then reduced to zinc. जिंक ऑक्साइड देन रिड्यूस्ड टू जिंक. रिड्यूस्ड मीन ऑक्सीजन घट गया, ऑक्सीजन यहाँ से रिमूव हो गया, जिंक फॉर्म में है, मतलब रिड्यूस हुआ है. दिस जिंक ऑक्साइड इज देन रिड्यूस्ड टू जिंक बाय यूजिंग अ सुइटेबल रिड्यूसिंग एजेंट. व्हाट इज द सुइटेबल रिड्यूसिंग एजेंट? दिस इज कार्बन. ओके, दिस इज कार्बन. कार्बन यूज एज रिड्यूसिंग एजेंट टू फॉर्म जिंक फ्रॉम जिंक ऑक्साइड. ओके, okay, beside using of carbon as reducing agents, metal oxides to metals. Okay, beside using carbon as reducing agents from metal oxides to metals, there are another metals that also use as reducing agents. Okay, what are the metals, another metals? Okay, that is sodium, calcium, aluminium, etc. are also used as a reducing agent because they can displace the metal of lower reactivity. Okay, because of reactivity. Okay, because of reactivity, sodium, calcium, aluminium they can displace the metal of lower reactivity from their compounds. Example given, when manganese dioxide is heated with aluminium powder, the following reaction take places. Okay, so what happened, and aluminium is more reactive than manganese. Okay, so aluminium displaces manganese. Okay, and form manganese and excessive heat production occurs. Okay, aluminium oxide produced हुआ है, manganese produced हुआ है. The amount of heat involved in such reaction is so large, okay, that the metals are produced in the molten state. This is the point. Another example of this type of reaction is that is the thermit reactions. Okay, another example of this type of reaction is thermit reaction, in which iron oxide, यहाँ पे देखो iron oxides reacts with aluminium. यहाँ पे एल्यूमिनियम आयरन को डिस्प्लेस करके एल्यूमिनियम ऑक्साइड प्रोड्यूस किया है, एंड यहाँ पे आयरन प्रोड्यूस हुआ है. एंड इन दिस प्रोसेस लार्ज अमाउंट ऑफ हीट इज प्रोड्यूस्ड. आयरन एल्यूमिनियम ऑक्साइड इन्वॉल्विंग लॉट ऑफ हीट. ओके, दिस इज द प्रोसेस. ओके, सो इन दिस स्लाइड we have seen that besides carbon we can use sodium, calcium, aluminium as reducing agents to get metal from their metal oxides. Okay, but what is the problem? Problem is by using sodium, calcium, by using aluminium as by using aluminium as reducing agents, lot of heat is generated. Okay, okay, now extractions of metals of low reactivity. What is low reactivity metal? The metals at bottom of the reactivity series, are least reactive. Obviously, they are often found in free state. Example given, gold, silver, and copper. But copper and silver are also found in the combined state as they are sulfide or oxide ore. Okay, as they are sulfide or oxide ores. Okay, देखो एग्जाम्पल लिखবেন कॉपर which is found in copper sulfide in nature can के इसको हम कॉपर सल्फाइड क्यूप्रस सल्फाइड okay copper which is found as copper sulfide in nature can be obtained from its ore by just heating in air okay यहाँ पे रिएक्शन देखो कॉपर सल्फाइड ऑक्सीजन इन द प्रेजेंस ऑफ एयर हीट किया है क्यूप्रस ऑक्साइड एंड सल्फर डाइऑक्साइड प्रोड्यूस हुआ है एंड देन क्यूप्रस ऑक्साइड एंड कॉपर सल्फाइड का इन द प्रेजेंस ऑफ हीट रिएक्शन में कॉपर एंड सल्फर डाइऑक्साइड प्रोड्यूस हुआ है इन दिस वे copper we can get copper from its ore okay so extractions of metal of low reactivity is done okay देखो similarly cinnabar is an ore of mercury this is very important question okay cinnabar is an ore of mercury when it is heated in air देखो यहाँ पे देखो cinnabar is heated in air it first converted in mercuric oxide okay first converted into mercuric oxide okay then the mercuric oxide is then reduced to mercury on further heating अगर अब mercuric oxide को हीट किया जाता है तो mercuric oxide reduced होता है mercury में and oxygen produce होता है यहाँ पे okay okay now what is refining of metal देखो what is refining of metal the metal produced by various reduction processes described above are not very pure okay they contain impurities which should be removed okay to obtain pure metals the most widely used method for refining impure metals is electrolytic refining okay next come to the corrosions of metal what is corrosion of metal corrosion is degradation of material corrosion is degradation of material due to reaction with its environment so simple the major problem of corrosion occurs with iron since it is used as a structural material in construction bridges shipbuilding automobile etc okay so the major problem of corrosion occurs with iron okay देखो have you ever observed old iron grills in the buildings copper vessels which are not cleaned for a long time silver ornament or idols which are kept exposed to air for a long time old worn out cars iron react with moist air to acquire a coating of brown flaky substance called rust okay this is important what is rust iron reacts with moist air to acquire a coating of brown flaky substance called rust okay copper reacts with moist carbon dioxide with air and slowly loses its shine to gain a green coat of copper carbonate okay this is also important okay so all are the reactions of metals with the environment okay with the environment air okay okay what happened in case of silver article becomes black after some time when exposed to air because it reacts with hydrogen sulfide in the air silver article reacts with hydrogen sulfide in the air form a coating of silver sulfide okay reacts with hydrogen sulfide and form silver sulfide okay as a result of this black silver article become black okay what happened to aluminum undergoes an oxidation reactions okay we all know that forming a thin layer of aluminum oxide which acts as a barrier to oxygen and water preventing the further corrosion okay oxidation and resistance to further corrosion okay सो एल्यूमिनियम ऑक्साइड का जो लेयर एल्यूमिनियम का ऊपर फॉर्म होता है वो एल्यूमिनियम का फर्दर करोशन होने से रोकता है ओके दिस रेसिस्टेंस कैन बी इम्प्रूव्ड by making the thin oxide layer thicker example anodizing okay anodizing reactions and by anodizing reactions aluminium article making more resistant to corrosion okay because a thick aluminium oxide coat is formed over aluminium by anodizing process. So prevention of corrosion, this is very much important questions of exam perspective of view okay. So corrosion of metal can be prevented if the contact between metal and air is cut off. Okay, so this is done in a number of ways. The contact between metal and air is cut off, and this is done in the number of ways. Some of the methods are given below. Okay, number one method, number two method. Number one method, corrosion can be prevented if the metal is coated with something which does not allow moisture and oxygen to react with it. Okay, such as example aluminium with aluminium oxide. Okay, coating of metals with paint, oil, grease or varnish prevents the corrosion of metals. Example given, rusting of iron can be prevented by this method. Okay. Oh, okay. There is another process of prevention of corrosion. Okay, coating of corrosive metals with non-corrosive metal. Coating of corrosive metals with non-corrosive metals also prevent corrosion. Some of the methods by which metals can be coated with non-corrosive metals are galvanizing, tinning. Okay, galvanizing and tinning. What is galvanizing? Galvanizing is a process of giving a thin coating of zinc on iron or steel to protect them from corrosions. Example given, shiny iron nails, pins, etc. These all are galvanized. What is tinning? It is the process of a giving of coat of tin. Okay, it is the process of giving a coating of tin. That is molten tin over other metal. Okay, that is molten tin over other metal. This is called tinning. What is example? Example देखो cooking vessel made up of copper and brass get greenish coating due to corrosion. Okay, cooking vessels made up of copper and brass get greenish coating due to corrosion. This greenish coating is very much poisonous. Okay, therefore they are given a coating of tin to prevent corrosion. Okay, this is also called kalai. Kalai is the procedure by which there is kalai is the procedure by which a coating of tin is given over the copper and brass to prevent its corrosion. Okay, and this is overview of galvanizing process. देखो degreasing, polling, rinsing, flux solutions, hot plate, zinc bath, quenching, then inspections. Okay, this is an overview of galvanizing process. Now, what is electroplating and what is anodizing? देखो, in electroplating, at first electroplating, in electroplating, in this method, a metal is covered with another metal using electrolysis. Okay, we all know that electrolysis cathode anode use होता है. Silver plated spoons. Okay, gold plated jewelry etc. are electroplated. Okay, example, what is anodizing? In this method, metals like copper and aluminium are electrically coated with a thin strong film of their oxides, and this film protects the metals from corrosions. Okay, this process is called anodizing. Okay, this is electroplating and this is anodizing process. Okay, by means of electrolysis, silver plated spoon is produced. Okay, by electroplating, and by means of anodizing process, aluminium oxide coat is formed outside the aluminium. Okay, so this is the anodizing process image. Okay. Okay, alloying. What is alloying? An alloy, so at first we should know that what is alloy. Okay, an alloy is an homogeneous mixture, okay, of two or more metals or a metal and a non-metal in definite proportion. This is important, in definite proportion. Okay, the resultant metal called alloy do not corrode easily. Example given, stainless steel and iron. Okay, then brass and then bronze. So what is brass? Brass is made up of copper and zinc, that is brass, and bronze is copper and tin. Okay, stainless steel made up of iron, nickel, chromium and carbon. Okay, stainless steel, the first example, iron, nickel, chromium and carbon. Okay, so alloying agent देखो क्या क्या है, एलॉइंग एजेंट क्रोमियम है, वेनेडियम है, निकेल है। सो इसका प्रॉपर्टीज एंड यूजेस देखो। एट फर्स्ट क्रोमियम का प्रॉपर्टी क्या है, रेसिस्ट वायर, ओके, रेसिस्ट वायर एंड इंक्रीजेज कोरोशन रेसिस्टेंस, ओके। एट फर्स्ट इंक्रीजेज हार्डनेस एंड टफनेस, ओके। एंड इसका यूजेस क्या है, स्टेनलेस स्टील, किचन यूटेंसिल्स एंड मेडिकल इंस्ट्रूमेंट्स, ओके। नेक्स्ट कम टू वेनेडियम्स का प्रॉपर्टी क्या है, इंक्रीज्ड स्ट्रेंथ एंड टफनेस ऑफ स्टील इंक्लूडिंग वायर रेसिस्टेंस, ओके। एंड यूजेस क्या है, क्रैंक शैफ्ट्स, सम हैंड टूल्स, सर्जिकल इंस्ट्रूमेंट्स यूज वेनेडियम, ओके। निकल्स का प्रॉपर्टीज क्या है, इंक्रीज्ड स्ट्रेंथ एंड हार्डनेस, रेसिस्टेंस टू कोरोशन, ओके। यूजेस क्या है, इंजन पार्ट्स, टर्बाइन ब्लेड्स, मेजरिंग टेप्स, ओके, यहाँ पे निकेल यूज होता है, ओके। एट फर्स्ट यहाँ पे देखो ब्रास कॉम्पोजिशंस 15 to 40% जिंक एंड 60 to 85% कॉपर, ओके। यहाँ पे अनदर थिंग्स है उसका देखो, स्कल्पचर ब्रोंज क्या क्या कॉम्पोजिशन है, कॉपर है, ये कॉपर एंड ये है आपका टीन, ओके। सिलिकॉन ब्रोंज, ये है सिलिकॉन, ये है कॉपर। ब्रास क्या क्या कॉम्पोजिशन क्या क्या है, ये है कॉपर एंड ये है जिंक, ओके, कॉपर जिंक, दिस इज ब्रास। एंड गन मेटल में क्या क्या है, कॉपर है, ओके, स्लाइट अमाउंट ऑफ टीन है, लेड भी है, स्लाइट अमाउंट ऑफ लेड है एंड स्लाइट अमाउंट ऑफ जिंक भी है, ओके, इन गन मेटल। Okay, now comes to what is amalgam, okay. in alloy if one of the metal is mercury, if one of the metal is mercury, then the alloy is known as an amalgam. This is very much important questions, okay. Next come to the pure gold. What is pure gold known as 24 karat gold, but it is very soft. 24 karat gold is very soft, it is therefore not suitable for making jewelry, okay. So what happened, it is alloyed with either silver or copper to make it hard, okay. It is generally in India 22 karat gold is used for making ornaments. It means that 22 parts of gold, it means 22 parts of gold of 22 parts of pure gold. It means 22 karat gold means that 22 parts of pure gold is alloyed with 2 parts of either copper or silver, okay. Okay, thanks to everyone. Kindly like, share and comments the video.